What is up, guys? My name is Susan, and welcome back to my study with me session. Today, I'm going to start pointers, so let's be ready to learn with me. So, let's start. Okay, pointers. Oh, do I have Visual Studio Code or not? Let's create a folder to practice, or we can use online GDB, not online gambling, GDB. I don't do gambling, guys. Gambling is bad, very bad. Include Ustream using namespace std int main. Okay, so yeah, so pointers. Let me make notes and create a folder and use notes. Let's write computer notes and let me create new and yeah. Let me create computer F2. Okay, so yeah, so concept, the address operator address return the memory of a variable. So I know that pointers are used to store address of a variable. Yeah, so every variable is allocated to a section of a memory large enough to hold a value of a variable data type. On a PC, for instance, it's common for 1 byte to be allocated for chars, 2 bytes for shorts, 4 bytes for ints, longs and floats, and 8 bytes for doubles. Each byte of memory has a unique address. A variable address is the address of the first byte allocated to that variable. Suppose the following variables are defined in a program: char letter, short float, float amount. Okay. Mm, Figure 1. Okay, let me add comment. Okay, I think I can add comment by doing this and exit. Sort is type of integer. What is the memory of SSO sort in C++? I'm going to use ChatGPT to answer my question for my questions. ChatGPT, okay. ChatGPT, okay. What is the memory of what is the memory of sort in C++? Oh, okay, so it only take 2 bytes. 2 bytes. Okay, so Integer takes 4 bytes, but sort takes 2 bytes of memory. Okay, so floats also take 4 bytes, longs also take 4 bytes. Okay, and what about long? What about long? I think 8. It might be 8. Okay, yeah, 8 bytes, 64 bits. Okay, okay, long takes how many bytes? 8 bytes. Okay, so here later number amount. Okay, yeah, later number amounts. Yeah, so later char will store how many? 1 byte. Okay, to be allocated for char will store 1 byte. So let me write something. Here is 1. Yeah, sort will 4, and float will be 4. Okay, so 144. So this is one number which is 4. Why there are two? Okay, in the figure the variable letter is shown at address 1200. Okay, and the number is at address 102. Okay, 1201. Okay, 4 bits. Okay, oh, okay, yeah, here 1 bit, 1 bit, 1, and here is 2. Sort is taking, yeah, sort is taking 2. Sorry, I thought sort took 4. i I thought it was integer for a minute. So it will take 2, and yeah, this is float, so this is taking 1 2 3 4. Okay, yeah. Okay, guessing the address of the variable is accomplished with an operator in C++. When the address operator is placed in front of variable name, it returns address of the variable. Okay, um, here is an expression that returns the address of an variable. Okay, so if this is variable, and if we put address or ampersand address operator, then it will be address of address of address of that variable. It will display the address of this variable. For example, if we do cout this, then it will display the address. Okay, okay, do not confuse address operator with this symbol used when defining a reference variable. Okay, yeah, yeah, this operator is also used for referencing. So yeah, okay, let me highlight this. Okay, okay, let's look our first program from 9.1, and this program uses the AND operator to determine a variable address and the size of operator to determine its size. Okay, include iostream using namespace. Okay, so here we have x, and its value is 25. Then yeah, this will provide the address of x, and this will provide the size of will be like bytes. Okay, this will be in, so it will provide 4, and the value of x is 25. So yeah, and it will provide the address where it is stored. So let me try this. Okay, int x equals to, let's put 10, COUT. Let's only print address of 10. So let me select a language, C++. Let me run. So yeah, this is the address. So address will be like this. Okay. Oh yeah, there is the address and 425. Yeah. Okay, pointer variables. Okay, we talked about. Now we are creating variables, pointer variables, which are often just called pointers. Okay, are designed to hold memory address. Okay, yeah, we cannot. I think we cannot, you know, hold address in x in one of the variable, but with the help of pointer we can store address. Okay, a pointer variable, which is often known as a pointer. Okay, these are same. A pointer variable is often a pointer is a special variable that holds a memory address. Okay, just as int variable are designed to hold integer, double variables are designed to hold floating point numbers, pointer variables are designed to hold memory address. Okay, got it. Memory address identifies specific location in the computer memory. Because a pointer variable holds a memory address. Okay, yeah, it can be used to hold location of some other piece of data. This should give you a clue as to why it is called a pointer. It points to some piece of data that is stored in a computer memory. I like this line. Pointer variables also allow you to work with data that they point to. Okay, we can also work with another data, and we already use memory address in this book to work with data recall from chapter 6. I have not read this book completely because I know most of this, like above chapters. So yeah, so for example, const int size equals to 5. So this 5, this size cannot be manipulated with the help of const. Int number size. Okay, so 5, 1 2 3 4 5. Okay, yeah. And so values, will be numbers by size. This code are passing the name of array. Yeah, this is the array, and numbers and its size as arguments to the subvalue function. Okay, here is the definition of subvalue function. Okay, let me see it live for a minute. Yeah, we are going good. Okay, so this is a function with subvalues, in values, in size. Okay, so in this function I think we are taking values. Okay, this is an array, and in size is 5. Size is 5. I don't know why uh, it's not there const, because there should be const. I think there should be const because here it is const. So int count. Okay, it will round up to 5, and count plus plus value count. Okay, so in this function the value parameter receives the address of a number array. It works like a pointer because it points to the number. I know that we don't need arrays to make pointers, because if we pass array to a function, then it will work with their address and the value will be changed. It will not make duplicates of its uh, values in a function. So in a function, the value parameter is the address of the number arrays is okay. Okay, so number of array, okay, 1 2 3 4 5, these are the value of their is particular elements, and so values numbers, then there will be address will be address will be linked when we are declaring function, and this is size is 5, so yeah, 5 will be here. So uh okay, if it was not array, then it would be make copies, or duplicates, but since it is array, so address will be passed. Okay, I got that. Okay, next, inside the show value function, anything that is done to the values parameter is actually done to the number array. Okay, yeah, means whatever we do with the values in array, especially in array. Okay, we can say that values parameter references the number arrays. Also recall from chapter 6 that we discussed reference variables, or reference variable act as an alliance for another variable. Okay, it is called reference variable, and because as its reference another variable in the program. Yeah, if it was integer, only integer, not an array, then we have to use address value to link its to where is the yeah, to link its values, since it is array, so we do not know this. Okay, this is easy. Anything that you do to the reference value is actually done with the value. Yeah, for example, suppose we have variable jelly donuts and we pass the variable to get order function. Okay, okay, so it is in jelly integer. Yeah, we need address here, address operator, because this is integer, not array. If it was not array, if it is integer, then we need address, otherwise there is the exception in array. Yeah, okay. In the function, the donors parameter is a reference variable and is received the address of a jelly donut variable. It works like a pointer because it points to jelly donuts variable as shown in figure 9.3. Okay, get inside the get order function, the donuts parameter reference jelly donut variable. Anything that is done to donuts parameter is actually done to jelly donut variable. Yeah, because we are using address operator. Because of this, when the user enters a value, the scene statement uses do not reference variable to indirectly store value in the jelly donuts variable. Yeah, notice that the connection between donut reference variable and jelly donuts argument is automatically established by C++ when the function is called. When you are writing this code, you don't have to go to trouble of finding memory address of jelly donuts variable, then properly storing that in donuts reference. Okay, I think I have left something here. Do not reference variable to indirectly store. Okay, yeah, it's same. Yeah, we're using address operator or ampersand, so it is linked with address. If we do not use this, then it will be linked, it will create new duplicates, create duplicates. Okay, get order. Okay, variable. When you are storing a value in Donors variable, you don't have to specify that value should actually be stored in Donors variable. C++ handles all that automatically. Again, storing a value in Donors variable, you don't have to specify that the value should actually be stored in Donors. Okay, yeah. We do not have to specify that it has to be stored in jelly nodes. If we are calling function you know like this, and we are using you know inside a function, then these two will be linked. Jelly nodes and nodes will be linked, so it will automatically source for its address. Yeah, in C++ pointer variable are yet another mechanism for using memory address to work with pieces of data. Pointer variables are similar to reference variable, but pointers variables operate at lower level. Okay, so I think this is the most important point I have ever heard up to now, because of this, because it is saying that pointers variable are similar to reference variable. Yeah, I know that, but pointers variable are pointer variables operate at lower level, means they consume less power, less memory. Is it true? By this I mean does not automatically do as much work for you with pointers variable as it does with reference variable. In order to make a pointer variable reference another item in memory, you have to write code that fetches the memory address of that item and assigns the address to the pointer variable. Okay, it is showing the, it is telling the steps to create pointer variables. Okay, also when you use pointer variable to store a value in a memory location that the pointer reference, your code has to specify that value should be stored in the location referenced by the pointer. Okay, yeah, this is also important. Okay, yeah. Whoa, what is this? Okay. Okay, because reference variable are easier to work with, you might be wondering why would we ever use pointer at all. Yes, my question is that in C++ pointer are useful, even necessary for many operation. One such operation is dynamic memory allocation. Okay, so it is used for dynamic memory allocation. When you are writing a program that you need to work with an unknown amount of data, dynamic memory allocation allows you to create variables, arrays, more complex data structure in memory while program is running. You will discuss dynamic memory allocation in greater detail in this chapter. Okay, yeah, I need to go. I will go to dynamic memory allocation after these pointers. So my next stream will be about dynamic memory allocation. Pointers are also very useful in algorithm that manipulates array and work with certain types of string. Okay, in OOP or object oriented programming, which you will learn about chapter 13, 14, and 15. Pointers are very useful for creating and working with object and for sharing access to object. Okay, we are also going to use for 13, 14, and 15. So let me see. 13 is introduction to classes. Okay, and inherit. Oh yeah, I think we will need this pointer. Creating and using pointer variables. The definition of pointer variable looks pretty much like any other definition. Okay, so this is the way to create integer pointer variable. Okay, so okay, the asterisk in front of the variable name indicates that pointer is a pointer variable. Okay, The int data types indicates that pointer can be used to hold address of an integer variable. Okay, the definition statement above would read pointer ptr is a pointer to an int. Okay, note in this definition the word int does not mean that ptr is an integer variable. It means that ptr can hold address of an integer variable. Remember, pointers only hold one kind of value, an address. Okay, got it? Okay, some programmers prefer to define pointers with the asterisk next to the type name. Oh, okay. Okay, so we can do here also and here also. Okay, that's interesting. Okay, this style of definition might be visually reinforced. Oh, sorry. That the fact that ptr data type is not int but pointer to int. Okay, both definition styles are correct. Okay, so both are correct. It's never a good idea to define a pointer variable without initializing it with a valid memory address. Okay, so I also know the thing that we cannot we can store its value. We cannot do this. We have to do equals to null like this. I don't know, but I think I will find my answer here. Let's hope. Okay, initializing it with a valid memory address. If you inadvertently use an uninitialized pointer variable, you will be affecting some unknown location in memory. Okay, yeah, for that reason it's good idea to initialize pointer variable. Okay, uh okay, null pointer. Okay, it is a special keyword, reserved keyword for indicating the end of C string. Null pointer is like end of anything. For example, end of an array. For example, this is previous and there will be imaginary or something like null pointer here to indicate that this is over. Reading is finished like this. Okay, in C++, the null pointer keyword was introduced to represent the address 0. Okay, yeah. Okay, I got my answer here. The null pointer keyword was introduced to represent address 0. So assigning null pointer to a pointer variable makes the variable point to address 0. Okay, when a pointer is when a pointer is set to address 0, it is referred to a null pointer because it points to nothing. Okay, here is an example. Okay, and this is the way to define null pointer. I think we can also define by null, capital N-U-L-L. Let me try later. If you are using an older compiler that does not support C++11 standard, that's why I like this, because there is, I think there is not 11. Okay, standard usually initialize pointers with the integer 0 or the value null. The value null is defined in the iostream header file as well as other header file to represent the value 0. Okay, let's see another program. So here is variable, here is pointer declaration to null pointer. So its value is address, its address is 0. ptr, okay, ptr, yeah, so it's a variable name and it is holding the address of x, and The value of x is x, the value address of x is this. Okay, let me do this program. So is x, let me create int, oh what is this, okay, ptr equals to, let me write null, because I know that null pointer will be correct. Let me try this. And ptr equals to address of x, we have to do this in pointer. And let me display, sorry. So first it will display, if I do this, then it will display the value of x. Let me use initial and COTs, and let me use, I'm checking my live, okay, yeah, it's on. Okay, now I have to use ptr to display address. Okay, I hope this will run. Oh, so it is not running, so I guess no, ptr is the correct way. Or yeah, it will run, I think. Yeah, let me just check 0 here. 0, does it run? Oh, it's running. So I can either put 0 or null pointer here. Okay, let me use like this, as book says. Okay, it's also running. Okay, 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 we are done. In program 2 variable are, okay, int variable x is int and the variable is pointer to an int, pointer to an int. Okay, I need to remember this, pointer to an int, pointer to an string, pointer to an float, anything, pointer to an short, pointer to an long. The variable x is initialized. Okay, no need to read this. Yes, so it will have the value. Okay, and do you know that I'm always confused about this? If I write, okay, I know that this will provide the address, this will display the same address, yes, but if I do this ptr, then it will display the value. Let me run 10, yeah. I'm always confused with this, like ptr, oh, is this the address? No, this is the value. If there is asterisk, then there is value. Okay, okay, the real benefit of pointer is that they allow you to indirectly access or modify the variable being pointed to. For instance, ptr could be used to change contents of variable. This is done with indirection operator, which is asterisk. Okay, okay, when the indirection operator is placed in front of pointer variable, it dereferences the pointer. When you are working with dereference pointer, you are actually working with the value of pointer is pointing to. Okay, so this is done with. Okay, let me look at this first. And okay, so value pointer declaration to null pointer or 0, pointer is holding now address of x. Oh, okay, yeah, so now I can change the, it is saying like I can indirectly change the value of x without calling x. So I can write like this, yeah, I can write like ptr, which is actually indirectly x, to value 100, and I can output x, which will display 100, I think. Yeah, so this is like indirect value manipulation manipulation. Okay, yeah. I don't know, I'm very weak with the spellings. Assign, okay, I got that. And use both x and pointer to display the value of x. See out once again, here is the value of x. Okay, yeah, do this. If we do this, it will display 100. So yeah, we know that. Okay, okay, ptr equals, this statement assigns the address of a x value. Yeah, we know that. Display contents of x. When you apply indirection operator to a pointer variable, you will working not with pointer variable itself, but the item it points to. Okay, so if we use x strict in pointer variable, then we will be working with its value itself. Okay, because this statement sends the expression ptr to cout object, it does not display the value in ptr, but the value ptr points to. Okay, since ptr points to the variable x, this statement displayed the contents of the x variable. Suppose the statement did not use the indirection operator. Suppose that the statement had been written as cout ptr india display and address. So guys, I think I have to finish my pointer lecture up to 9. Why it's not charging? Yeah, now it starts. Okay, okay, because the indirection operator is not applied to ptr in this statement, it will directly with pointer variable. This statement would display the address that is stored in ptr. Now take a look at. Okay, yeah, it was just explaining the previous program. Okay, let's look to another program. Okay, value declaration. X is 25, y is 50, z is 75. Pointer declaration to null pointer. Okay, displaying x, y, z, and storing the address of x to ptr. Okay, ptr plus or equals to 100. This means x value is 25, so it will be 1 to 5. Okay, and ptr equals to y. Now ptr plus equals to 100. That means y is now uh, 50. Oh, sorry, 150. Sorry, 150. And z, declaring the address of z, and doing adding 100, so 175. Okay, 125, 150, 175. Okay, no need to explain this, we got that. But let's still is used to pointer variable when we apply indirection operator with. Here we are working not with pointer but with the item. Okay, I got that. I did not know that, but yeah, interesting. The relationship between array and pointers. Okay, array names can be used as constant pointers. So names can be used as pointers. Pointers can be used as array names. Okay, you learn in chapter 7 that an array name without brackets is a subscript actually representing the starting address of array. This means that array name is really a pointer. Okay, so array name is actually a pointer. Important, very very important. And this program shows an array name being okay. So this is an array, array, sort array, 10, 20, 30, 40, and 50, which only store two values. We can restore 100, 100, like 3 bytes. Next is first element of array is asterisk number. Oh, we are actually this is like ptr. Okay, this is like ptr, like pointer variable. If we use asterisk in front of pointer variable, then we are accessing its value. For example, like let me write int values, okay, no need to write that. Okay, is there a vector? No. Okay, sorry. What is wrong with this keyboard? What is wrong with this keyboard? Okay, yeah. Okay, so 1 2 3 4 5. Okay, and okay, yeah. Okay, so what is this? Okay, so if I do cout values 0, then it will display 1. I know that, display 1. But what if I do this asterisk? Where is asterisk? Yeah, 1. So it will display 1. So okay, numbers, then it's displaying. Okay, so first element of array plus 1. Okay, I think this will be this will come later. Okay, because number works like a pointer to starting address of an array. The first element is retrieved when number is dereferenced. Okay, so if I write like this, then there will be, wait a minute, what if it is 20? Because am I adding a value to 1, or it is showing this to value? Oh, it's only adding the value. Okay, so how could the entire container array? Remember, array elements are stored together in memory. It makes sense that if numbers is the address Address 0, number 0 value could be added to number to get the address of other elements in the array. It's important to know, however, that pointers do not work like regular variables when used in mathematical statements. I was trying to do that. When you add a value to a pointer, you will actually adding value times. Okay. So the size of data being referenced by a pointer. In other words, if you add one to numbers, you are actually adding one into size of sort to number. If you add two, this means the following are true. Okay, this number plus one is actually okay into two. Okay, and fourth. Let me use brackets. Should it will display 20? Yeah, it is displaying 20. And let me use 2 here. Yay, 2. Run. Okay. Two is actually 2. This is 3. And values plus 2 equals to 3. Both are 3. Let me see. 33, sorry. Yeah. Let me use India. Yeah, 3 and 3. So these two are same. So plus 1. I think it should be like 0 here. Is actually this. Because it is this, yeah. Sorry. So I have written this and this. Okay, yeah. I think let me add text here. Yeah, okay. Okay. Okay, let me learn this. Okay, this automatic conversion means that an element in an array can be retrieved by using a subscript or by adding a subscript to a pointer to the array. If the expression numbers, which is the same as this numbers 0, retrieves the first element in the array, then number plus 1 receive the second element. Likewise, number 2 receives the third element. Okay, yeah. And so forth. So numbers, so see, this is sort, so only 2 memory spaces. This is sort. So number 0, number 1, number 2, number 3, number 4. Numbers, I got confused by the way. Okay, yeah, I was here. Okay, numbers plus 1. Okay, numbers plus 2, numbers plus 3, numbers plus 4. 1, 2 to the 4. 2 times 4. This is equals to this. This is equals to this is equals to this. It's a bit confusing, but so into 2 will be like next, will be next, like this means okay, if we multiply by 2, let me add this comment. If we use x asterisk, sorry, asterisk, then 2, then we will get next element, get access to next element. Yeah. Yeah. Okay, I got that. Okay, program 916. This program process an array using pointer notation. Hashtag include iStream using namespace std. Okay, constant integer size 5. Okay, this is array count counter variable. Okay, get value. Use pointer notation instead of subscript. Okay. Okay, cout integer size numbers. Count equals 0, count size plus plus. If count is 0, numbers plus count. One is actually showing. What if I do 0 here? Run. 0 is 1. What if 1 is here? 21 into 2 is 30. Three. 0 1 2. I don't know. I'm not understanding this. This let me delete this. I did not understand that. I don't know why there is like multiplication of 2. Okay. Okay, I got that. Okay, this is a new way to do this. You know, accessing values. Okay, with the help of pointer. Okay, here are the numbers you have entered. Okay, reading and now displaying. Okay, I got that. Another is warning. Remember that C++ programs no bounds checking with arrays. When stepping through an array with a pointer, it is possible to give the pointer an address outside the array. It is possible to give pointer and address outside of the array. To demonstrate just how close the relationship is between array names and pointers, look at 9.7. Okay, let's look at 9.7. We are using IOmenu. Okay, why I'm doing this? Okay, I menu int main constant integer num coins 5 double coins. Okay, so we have num coins 5 and here is like values. We are creating a double pointer. Why is not there null? I don't know. If I was there I will do the non pointer. Okay, int count double pointer coin, and here we go. See out, here are the values in the coins array. Okay, okay, we can, yeah. So okay, we are, okay, so no need to add address because this is array, and we are doing this values in coin array. Okay, in array I think we do not need to use asterisk to get the values. As we are using here, we are using asterisk, but this is also an array of integer, array of double. Hmm. Because the name of array is already an address, use of address operator would be incorrect. You can however use the address operator to get address of an individual element in an array. For instance, this get the address of number 1, but this is array, this array, yeah, this is also array of integer. I think we do not need, like, we do not need. Okay, to demonstrate between names and pointers, look at that, names and pointer. Okay, oh, we are not using we are not declaring pointer variable here, so we have not used pointer variables, but we have used pointers operator. But we are using asterisk. Oh, we can use this also and this also. Oh, no, no, no. Okay, I think I got that. Okay, so let me write 5 here. Okay, now I will create pointer variable asterisk ptr in ptr, sorry, in ptr, and we are assigning its value to null pointer. Then we will do this in pointer equals to values. Okay, since it is array, no need to do anything, no need to add address because it is address, also address. So for int I equals to 0, okay, like this and up to 5, yeah, and I plus plus. Now I'm taking input, now it will be, so we are using like sin function, and we are using int ptr, int ptr, and I to take the value. Displaying, to display we are copying this and we are doing another from another method. So we are sin, no need to use NL here because this is input, and instead of cout sin we are using cout, and we are going to use asterisk, and what is the name, values, values values plus I. We can write return 0, RETU return 0, in pointer equals, oh, let me write in pointer. Okay, I think I did something wrong because I did not understand. Okay, it is using count, so I'm using I. What's the difference? Oh, I can only do cout because there is already a value. I thought I was taking. Not. Oh, sorry. My mistake. What is wrong with this? Let me use this. Okay. And non-coins, non-coin file. This nothing to do with. Let me use this, and third method. And what is wrong? 5 1 2 3 4 5. Okay, no pointer. Oh, here is not the value. Sorry, my biggest mistake is this. Like int, where is we have to make it? Yeah. Okay. Okay. Yeah. We are using values. let me use in here. Okay, 1 2 3 4 34 56. Okay, yeah. Okay, I was trying to do this from the beginning, but I forgot that there was a value inside there. So okay, so did I understand this? Was it that or this? Oh, it was this. Okay, now let's look 9.8. This program uses the address of each element in the array. Okay, same 5. There are 5 elements. Null pointer declaration to null point. No, sorry, pointer declaration to null points. Then count declaration or initialization. Use the pointer to display the value in the array. See out here are the values. Here are the values in the coins array. Okay, in this way I can display address, coins count. Okay, and okay, so the thing is I can write like I can do this like yeah, and I can put address here. This will display the address and this will show the value. 1 plus C, 1 plus B. Okay, let me write here Kindle. Here, no need of this. Okay, yeah. Input and display, and we are good to go. Okay, so here is 1, here is 20, here is 3, here is 4, here is 5. What is the another way to do this? Another way to do this is values run. And do you know another way to do this? No. Yeah, I think these are the only 2 ways to do this. Any other way? No other way. So yeah, this is another way. Okay, let's go to another. It's already 9. Warning: remember C++ performs no bound checking with arrays when stepping through an array with a pointer. It is possible to keep pointer and address outside the array. To demonstrate how close relationship, let me check my, yeah, it is going. Okay, so remember that C++ performs no bound checking with arrays when stepping through an array with a pointer. It is possible to give the pointer an address outside of array. To demonstrate that how close the relationship is between array and names and pointers. I was just looking at the stream. Okay. What was this? Did I do this? I think I completed this because what's this doing? Yeah, I have completed this. Okay, here the only difference between okay. Reduce totals. What is this? Array names and pointer variable is that you cannot change the address an array name points to. For example, consider the following definition. Okay, double readings. This is what is this? This is array. This is also another array. Double pointer dp. Okay, pointer declaration, pointer variable declaration to null pointer, and here is readings. Here is two. Readings equals to totals, illegal. Totals equals to dptr. I cannot do this. Readings equals to, cannot change readings. Okay. Okay, pointer arithmetic. Some mathematical operation may be performed on pointers. The contents of pointer variables may be changed with mathematical statements that perform addition or subtraction. This is demonstrated on program 9.9. Oh no. Okay. I thought it was charging, but okay. Let me check the stream. Let me see. Okay. Okay. Okay, now we are on pointer arithmetic. So mathematical statement that performs addition or subtraction. This is demonstrated in program 9.9. The first loop increments the pointer variable, stepping it through its elements of the array. The second loop decrement the pointer, stepping it through the array backwards. Okay, I need to see program because okay, 8 1 to 8, pointer declaration, count declaration, initialization, pointer initialization. Why I'm saying declaration? Okay, to set. Okay, we can do this, but we cannot do set to null pointer. This is allowed. See out the number in the set R. Okay, the number in set R. Okay, plus yeah, numptr plus plus. If I do numptr plus plus, then I don't know. Like in backwards R. Num So here is the term like num ptr plus plus and num ptr minus minus. If it was like variables, it will decrease the value, but the first loop increments the pointer variable, stepping it through each element of array. Oh, so it will first loop increment stepping it through each element of an array. The second loop decrements backward. So it is saying like null pointer and values. So I have to write this like int ptr and int ptr plus plus, then ptri. Isn't this right? Okay, sorry, in ptr, it is in ptr. Okay, okay, it is also in ptr. Sorry, bad again. Why the so in ptr it is printing 1 plus plus, that means 3. It is printing 3, then it is printing 5. Hmm. Oh, so it is using like only numptr. What if I do this? Oh, it is address. If I need to display value, then I need to do this. Okay, so I cannot use I. The thing is, if I got to know one thing, like if I do this, then it is just showing 1, 20, 30, 4, and 5. It's like this is the value. I'm trying to see the next value. What's the next value? And if I was using this, sorry, this, it was interesting. Like, look, first it print 1, then after printing 1, in print plus plus, then it looked 5. uh, in print plus plus. Oh, sorry, in print. Like it skipped this. Okay, it was interesting. I think we might study it later. And what if here was like let me try print plus plus. print minus minus. Let me remove this. Let me run. Okay, I don't know what it is string. 5 to 0. Size 5. Why there is 2 in here? Okay, so it's not working right now, or should I have to write like, okay, so in ptr plus plus, yeah, count plus c, 1 plus b, and let me remove this. Okay, after this I'm doing this backwards. Okay, this is, no, it's not working. Oh, now is it working? Now it's working. So now is it working? It's not working. It only works if I do this first. Okay, so let me understand, like so here is value 5, 1, 20, 3, 4, 5, and here is pointer initialization. Here is storing values, address in printer, ptr pointer, and this loop, and I am displaying value of in pointer. So if I do this, then it will it is like equals to doing this values, which means it is the first element. It is the first element. So if I do in ptr plus plus, then it will increase the it will go to the next value, goes to next value, go to next value, and this like backward, and I don't know, like okay, because n pointer is a pointer to an integer, the increment of operator adds the size of one integer to num pointer, so it points to next. Okay, size of one integer to and the pointer. This means like next values, add the size of one integer. Okay, likewise decrement subtract the size of subtracts the size of oh, okay, so I got it now. So it is like saying values first element. So uh, in this it will display 1. After that it adds the size of one integer, then it will be 20, then it will be 3, then it will be 4, then it will be 5. Here here after this completion of this program, int in ptr is like 5 or something. Let's say 5 memory address. So minus 1, you know, minus 1 4 minus like this 5, then 4, then minus, then y is not 4, y is 5. hmm. Oh, because okay, 1 plus 2 plus 3 plus 4 plus 5 plus, so it will be like 6, like this 6. Wait a minute guys, I got my mail. I got a lot of mails today. Okay. I forgot some of my important meetings and events. That's cool. Okay, so in this way, okay, now initializing pointers. What? We are here now? I think we did this. Okay, pointer may be initialized with the address of an existing object. Remember that a pointer is designed to point to an object of a specific data types. When a pointer is initialized with an address, it must be address of an object the pointer can point to. For instance, the following definition of int is legal because my value is an integer. Yeah. Uh, the following is also legal because is array of integer. Yeah. But the following definition of int is illegal because float is not an int. Okay. So we cannot do like float as like integers because it's illegal. Pointers may be defined in the same statement as other variable of same type. The following statement defines an integer variable, my value, then defines a pointer int which is initialized with the address of my value. So here is like my value, which is integer, which is initialized, and int, which is, I think it is pointer, and address of my value. And the following statement defines an array readings and pointer marker which is initialized with the address of the first element in the array. So this is the initialization of reading array. Marker equals to readings. Oh, I think, is this the way? Of course, a pointer can only be initialized with address of an object that has already been defined. The following is illegal because mint is being initialized with the address of an object that does not exist yet. Okay, so that is illegal. Okay, I did not understand this because okay, I need to watch like write a statement that uh, write a statement that displays an address of variable count. Okay, let's do some questions. Yeah, whoa, we got some questions. Okay, write a statement that display the address of variable count. So we have variable count that display the address. It will be like address and count, address count. And what is the definition of statement of variable flt ptr? The variable should be a pointer. Okay, write the definition statement of variable. Yeah, okay, the variable should be pointer to a float. Okay, what should I do now? Should be like to a float, pointer to a float. Okay, now it's time to ask my ChatGPT. uh, Initialize. Okay, right. Right. Okay, float. Hmm. It's like it's simple. Let me try. Sorry. Availability float num equals to 89.9. Uh, float availability float yaf ptr. Yeah, ptr. Let me use asterisk here, and let me use equals to here, and I'm addressing, yeah, num cout. I'm displaying the value, then I will display address. Okay, let me run this. Okay, yeah, it worked. So why it is saying like it's illegal? Oh, so it should be float for float. Okay, so here is my answer for question number 2. List 3 uses of this symbol in C++. So first use is this. We can use it like this, yeah, this symbol means three uses. So we can use as, you know, pointer, we can use for multiplications, then we can use for what else we can use it for, we can use for, I know that it is used in array like this. I was talking about this, like, where's the array? Oh, it's the same. Yeah, that means, I don't know what is I can only answer two. Three uses of this symbol in C++. Pointer declaration, dereferencing. Okay, yeah. Oh, pointer declaration, then dereferencing, then multiplication. Okay. Pointer declaration, here we can declare pointer variable for declaring pointer variable especially, and it's like dereferencing, you know, and for multiplication operator. Okay. Oh, sorry, my bad. Where are the questions? I got lost now. Okay, yeah. What is the output of the following code? 50, 60, 70. Shout first it will display 50, 60, 70, then it will add to it will add 60, it will display 60, 65, and 72. Yeah, rewrite the following loop. So it uses pointer notations. Pointer notations. Okay, how can I write? Okay, I can use like asterisk ARR plus 1 or plus X, like this. ARR, sorry, asterisk ARR, sorry, asterisk ARR plus X, like this. Also, PTR is a pointer to an int and holds address 12,000 on a system with 4%. What address will be in PTR after the following statement? Okay. Four byte integer. So it's already 1, 2, 3, 4. It will like this. I don't know, like, will it be like this or like this? 2000, either its answer is 2010 or 1210. What I have to choose? Like, I'm going for 1210. Let's see its answer. I'm going for 1210. Okay. 12,040. How 40? What? Okay, PTR is a pointer to an int and initially holds address. Oh, say it was address. Oh, I thought value. And PTR plus 10. 10 means pointer to an integer, which is like 40 into 40. So it will add like 1 to 40. Yeah. Sorry, my bad. Assume pint is a pointer variable. Is of the following statement valid or not valid? Okay. Valid, I think, is invalid, or I think this is also valid. And next is pint divide or equals to 2. I don't know, we can divide by 2. I think it's invalid. It's also invalid. We cannot multiply by 4. Yeah, it is valid. So yeah, it is valid because pint equals to pint can be like pint plus integer like this. But multiplication and division, I don't think it will be there. Okay, yeah, our one is right, second is right, invalid, yeah, and valid, yeah. Okay, next, each of the following definition valid or invalid. Okay, let's try again. Int Ivor, okay, int address Ivor. It is valid, yeah, it is valid, it is valid, yeah. And int Ivor, and okay, okay, it is also valid. Float is not valid, it should be float. Int nums 50, and where's the address? Oh, okay, it is address, so it is right. Int, okay, address Ivor, int Ivor. No, it's not valid because it should be declared first, because no need to check, but also let's check. I know no need to check, but let's go. Valid, 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 valid. Sorry, invalid, valid, invalid. Okay, we are right. Okay, comparing pointers. Okay, if one address comes before another address in memory, then first address is considered less than the second. Okay, guys, I will take. I need to use restroom right now, so just a break. Sorry guys, I was late because I went to fill the water. How to check comments? Like, is the camera quality low? Yeah, it's low, but it's alright. Is the camera quality low? Yeah, it's low, but it's alright. Okay, guys. Okay, I think let's say the contents. Like, I think we are in here. Pointers, chapter 9. Oh my god, okay. I think we are in comparing pointers right now. 9.6. So we need more this, and this. Okay. If one address comes before another address in memory, the first address is considered less than the second, the second. C++ is relational operators. C++ relational operators may be used to compare pointers value. Pointers may be compared by using. So we are like compare. Okay, yeah. Comparing pointers in an array. All the elements are stored in consecutive memory locations. So the address of element 1 is greater than address of element 0. Okay, so consecutive memory locations. So sorry, I'm getting disturbed. Bye bye. Okay. Okay. R0, R1, R0, R1, R2, R3, R4. Okay. 0, 0 plus 4 plus 8 plus 0C. Okay, these are addresses for example that. Okay, because the arrays grow larger for each subsequent elements in the array, the following if statements are all true. Array 1, array 0, array and array 4, array equals to and array 0, array 2, array 3. Okay, array 1 is okay, array 1 is greater than array 2. R is smaller than array 4. Okay, yeah. R equals to array 0. Okay, address, yeah, equals to R0, address 2 equals to, what is this, is not equals to, okay, true. Just a guys, just a bit. Okay, sorry. Okay, comparing two pointers is not the same as comparing values of two pointers. Point two, for example, if statement compares the addresses point stored in pointers variable ptr1 and ptr2, if ptr1 is smaller than ptr2, the following statement, however, compares the value that ptr1 and ptr2 points to. If ptr1 is smaller than ptr2. Okay, comparing two pointers is not same as comparing two values of the two pointer points to. For example, if, okay, this is comparing the addresses, and this is comparing the values. Okay, yeah, I thought it was like something else, but yeah, I don't know why they keep so, there should be like exceptional, exception, or like like really tricky one. I don't know why they keep, normal things in note. The capability of comparing address gives you another way to be sure a pointer does not go beyond the boundary of an array. Program okay, 9.10 initializes the pointer nums with the starting addresses of array set. The nums pointer is then stepped through the array sets until the address is content is equal to address of the last elements of the array. Then the pointer is stepped backwards through the array until it points to the first element. This program uses a pointer to display the contents of an integer array. Hashtag include iostream using namespace std int main int set 8 5 10 15 20. Okay, here is set, and here is set num, you know yeah, initializing and setting the value, and the number and set are okay. Nums first display first elements, while num is smaller. Nums, okay, so this is like, this is address, so this is address, so this is address, and this is address, and this is address of set 7. So okay, yeah, no, okay, so it will run. I think there is like num plus or something like that. I don't know. Yeah, there is a num plus plus. Okay, yeah, and it will run from nums a to 7. They can, okay, yeah, okay, address is 7. Okay, and last, okay, address of last plus plus. Okay, it's create a boundary. So before, we were printing, backwards and forward pointers in a forward way or in a backward way, but we did not use, like conditionals. So these are like conditionals. So nums is has to be small, bigger than a set. This like condition. Okay, so let's do this. Okay, let's try to do this. Okay, so let me create int values and like create like 6 elements here. Sorry, 5 elements. Let me put 5 and 1, 10, 20, 30, 40, 50. Okay, and in ptr equals to values, because it is what, array. Now after that I need to do is okay, this display in forward way. Okay, wow, values which is first is smaller than address of int ptr 7. I can write int ptr 7 or I can value 7, it doesn't matter, but I'm writing this because I need to adapt, like this, using both values and int ptr like that. And I can print the values. So for that I will use val values values. Okay, oh, values, no, sorry, int ptr, no, first I need to print the values, values I, then I need to do without using like int ptr plus plus, it will add the values. CUD in backward way, endl so let's leave it. So let's do like wall now int ptr is greater int ptr is greater than values int ptr minus and COUT values I values what is I here? We are not using I, so here should be like in ptr values of in ptr values of int ptr. Okay, let's run this. And I don't know what did I do. Okay, so I think I did this right. I did this right. Okay, I think in PTR, which is greater? In PTR is greater. So in PTR is greater, yeah, and values is smaller. It should be true. So values it should be right. Why it's not working? Let me use and values. Why I'm using 7 here? 5. 0. So nums is here. Where is nums? Nums is pointer and set is nums is like it is equals to values nums. I don't know what did I do wrong. Oh, plus plus will be front. But it's still originally same. Oh, I think there is no use of this short nums because it is just displaying the first element and it is displaying the last element. Oh, it's also okay. I think it's to matter. Try nums not nums values. It's wrong again. No, okay, so oh, okay. Let me check my. Oh, did I do something wrong? Look, nums is smaller than sets is like values 7 values 5. It's the same. Let me set Oh, oh, using use hashtag include sit. Oh, set is like, what is this set? It's like values, so and then values, values like run this. Now set instead of set values. It's not working. Why it's not working? Okay. Yes. In PTR is nice. Oh, I'm so stupid. It should be the answer. Okay. Now pointer function as parameters. Okay, in chapter 6 you will be introduced to concept of reference variables being used as a functions. Parameters or reference variables act as an allies to the original variables. Okay, it's like allies. Okay, this gives functions access to original arguments variables, allowing it to change the variable contents with when a variable is passed into a reference parameter. The argument is said to be passed by reference. Okay, let me highlight this. When a variable is passed into a reference parameter, the argument is said to. Another way to pass arguments by reference is to use pointer variable as the parameter. Another is use a variable as a parameter. What is this? Okay. Admittedly, reference variables are much easier to work with than pointers. Reference variables hide all the mechanics of dereferencing and indirections. You should still want to use pointers as function arguments. However, because some tasks, especially when you are dealing with strings, are best done with pointers, Also, the C++ library has many functions that use pointers as parameters. Okay, so void double value int val. Okay, so we are using uh, pointer pointer as the parameter, pointer variable as a parameter, and reference variable had all the mechanics of dereferencing and indirection. You should learn to use pointer as function. However, because some tasks, especially when you are dealing with strings, are best done with pointers. Also, the C++. Okay, so I I take pointers parameter, then I multiply that like using as usual as variables. Okay, and I have and in function I have to pass what is this address of a number. Okay, this program uses two functions that accept addresses of variables as arguments, include iostream. Okay, sorry. There are two functions, get number, double value int, you know, get number and double value. Okay, initializing number, so call and get number. Oh, here are the, so get number. I pass the address of a number, double value, address of a number, set the value double is number. Okay, get number. I don't have game pass. Sorry. Cout enter an integer number. Okay, we're using like variables, but using an asterisk in front of it. So another is void double value int val, and okay, yeah, this is easy. Program output with example in slow, so bold. Okay, okay, let's look this function. iostream imanu using namespace std function prototype void get cells double asterisk int double total cells double int. Okay, and okay, so I don't know, qtrs is constant and cells qtrs get cells data from all quarters, get cells qtrs sets the numeric output formatting, cout fix so point. Okay, so okay, so point, what is, where is so point here? How we are out, where is so point? Are we returning so point? Cells fix so point. Okay, what is the use of so points, oh sorry, so points in C++? Force display the decimal points and trailing zeros for floating numbers, even they are whole numbers. Oh, even they are whole numbers. Num2. Oh, okay, so points without so point 25, 15, 25. Okay. Okay, I got that. And another is so let's see, double cells, which is array. We are, you know, we are using the values of array array here, and in size I think in size UTRs. Okay, okay, for array. I don't know why they are using array like this, because for array we don't need address, because they automatically work with this, connected with their address. Okay, double. Oh, it's an array. Yeah. Let me put this. Okay, let me copy this. I'm asking a stupid question. I know that it's array, but still. Yes, it's array. And why we are using this? Okay, notice that in the getCells function in program 92, even though parameter r is defined as pointer, subscript notation is used in the scene statement, and line 39, scene array count in total cells array is used with indirection operator in line 54. Okay, I think I need ChatGPT right now because I have some questions. Is that all? Many things here. No, I hate this. We copy, paste, and I'll go right back. Why we are using strcrr? Don't we only use arr? Weird question. The reason is using is due to how pointers in array or is are equals are. Oh no. It's like C programming language. So if we use R, when you pass R, a pointer to array in a function, R holds the address of the first elements in the array. It's not the value of first elements, but rather the memory location. Okay, so this is like memory location, whereas this is the actual value of the first element. I use ARR is a function tool. So okay, okay, I got that. Okay, I will be back. Do it. What's up, guys? What's up? So pointers to constant. Okay, let's read the note first. The two previous statement could be combined into the following statement: sum plus equals to. So pointers to constant. You have seen how an item address can be passed into a pointer parameter and how the pointer can be used to modify the item that was passed as an argument. Sometimes it is necessary to pass address of a constant item into a pointer. When this is the case, the pointer must be defined as a pointer to const item. For example, consider the following array definition. Okay, const in size 6, const double pivot size. Okay, this is an array and this in this code pay rates. Okay, pay rates is an array of const double. This means that each element in the array is const double, and the compiler will not allow us to write code that changes array contents. If we want to pass pay rates array into a pointer parameters, if we want to pass pay array pay rates array into pointers parameter, the parameters must be declared as a pointer to const double. Okay, so these are constant values, and if we want to use pointers, pointers, then we are also going to declare a pointer to const double. Okay, so void display periods const double rates in size. Okay, set precision fix so point uh, so point. Okay, for int count equals to 0, count size employee 1 is rates per count, which will rates plus 0, count plus 1. What is count plus 1? Oh, 0 plus 1 equals to 1. Okay, yeah, and rates plus count is this. So in this function header, notice okay, constable, the asterisk indicates that rates is a pointer. Okay, rates is a pointer. What is the rates points to? Because rates is a pointer to a const, the compiler will not allows us to write a code that senses the things that rates points to. In passing the address of constant in a pointer variable, the variable must be defined as pointer to a constant. If the word constant has been left out of the definition of the rates parameter, and a compiler would have resulted. Okay, passing a non-constant argument into a pointer to a constant. Although constant address can be passed only to a pointer to constant, a pointer to constant can also receive the address of non-constant item. For example, look at program 9 to 13. Okay, this program demonstrates a pointer to const parameter. Okay, has stack include our string username space std. Okay, we are using const in pointer and integer, constant in size, and constant in array size 1 2 3 4 5 6. Okay, size 6, so there are 6, and we have another array too, and it has 2 4 6 8 10 and 12. Display the contents of the constant array, and we are displaying array 1 and size displaying array 2. Okay, numbers in size. Okay, count equals to 0, count is smaller than size, count plus plus, numbers plus count in here. Okay, pointer to const or a const pointer. A pointer to const points to a constant items. The data that pointer points to cannot sense, but the pointer itself can sense. It is a const pointer. It is a pointer itself that is constant. Once a pointer is initialized with an address, it cannot point to anything else. Okay, int value equals to 22, int pointer const equals to address value. Notice in the definition of ptr, the word const appears after asterisk. Okay, this is the, I think, very important. This means that ptr is a const pointer. This is illustrated in figure 9.9, and hit the code. const indicates that ptr is a constant pointer. Okay. Constant pointer must be initialized with a starting value as soon as previous example code. If constant pointer is a function parameter, the parameter will be initialized with the address that is passed as. So it is constant pointer, so it should have value because later it can be changed, so it should have value. The address that is passed as an argument into it and cannot be changed to point to anything else. Anything else. Here is an example that attempts to violate this rule. Okay, void set to 0. Error, cannot change the contents to ptr. Yeah, because it is constant, so we cannot change this value to 0 unless uh, this value is already 0. I don't know, but okay, this function parameter ptr is a constant pointer. It will not compile because we cannot have code in the function that changes the contents of ptr. However, ptr does not point to a constant, so we can have code that changes the data that ptr points to. ptr. Oh, so this is the address. This is the address, and this is the address, but this is the value. We can change the value, but we cannot change the value. This is value and this is address. Yeah. So value can be changed, but the address cannot be changed. Constant pointer to constant. So far we have using constant with pointer. We have seen pointers to constant, and we have seen constant pointers. You can also have constant pointers to constant. For example, look at the following code. Okay, int value 22, const int const pointer. Oh, okay. Now it is like fix and fix and fix. We cannot do anything. Like once we declare this, then this will be like ultimate like permanent address with permanent value in a function. Okay, I got this point. Okay, void display const length, const number, in size, in number. So how to call this? I think only address and number. Yeah. So number plus 1. Okay, yeah, we are not sensing anything, we are just displaying. So focus on software engineering. Dynamic memory allocation. Variables may be created and destroyed while a program is running. Okay, concept is very important. Like variables can be created and destroyed while running a program. Okay, as long as you know how many variables you will need during the execution of a program, you can define those variables upfront. For example, a program to calculate the area of rectangle, which will need three variables: one for rectangle length, one for rectangle width, and one to hold the area. If you are writing a program to compute the payroll for 30 employees, you will probably create an array of 30 elements to hold the amount of pay for each person. But what about those times when you don't know how many variables you need? Okay, you're writing a program to compute payroll for 30 employees. Okay, how many variable you need when you don't know how many variable you need? For instance, suppose you want to write a test averaging program that will average any number of tests, any number of tests, average any number of tests. Okay, obviously the program would be very versatile, but how do you store the individual test score in memory if you don't know how many variables to define? Quite simple. You allow program create its own variable on the fly. This is called dynamic memory allocation. Okay, okay. So so you allow the program to create its own variables on the fly. Okay, we are allowing program to create their own variables. This is called dynamic memory allocation, and it is only possible through pointers. To dynamically allocate memory means that a program, while running, asks the computer to set aside a chunk of unused memory large enough to hold variable of specific data type. Let's say a program needs to create an integer variable. It will make a request to computer that it allocate enough bytes to store an int. When the computer fills this request, it finds and set aside a chunk of unused memory. Okay, so it is explaining the process. Okay, let's go from again. Let's do that again. Like, to dynamically allocate memory means that program while running asks the computer to set aside a chunk of unused memory large enough to hold variable of a specific data type. Let's say a program needs to create an integer variable. It will make a request to computer that it allocate enough bytes to store an int. When computer fills this request, it finds and set aside a chunk of unused memory large enough for the variable. It then gives the program the starting address of chunk of memory. The program can only access the newly allocated memory through its address, so a pointer is required to use those bytes. So the thing is, in memory dynamic location, uh, if we are using it, then computer tells that if we need integer as a memory dynamic location, then it will request the computer to set aside memory required for integers or for float or for variable for sort anything or anything. And after that it uses, it creates the, or it uses the storage unused memory for 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 that variable, and we can access those variable only through address. There is no other way. So in that way we need pointers. Okay, the way a C++ program requests dynamically allocated memory is through new operator. Assume a program has a pointer to an int defined as, okay, yeah, this is pointer declaration to null pointer, and pointer is new int. Here is an example of how this pointer may be used with new operator. Okay, we got the new trump, which is new operator. So what is new in C++? Okay. What is the use of new in here? So in expression, this new operator is a dynamic allocate memory for an integer on the heap, assign address of the memory to the pointer. Here what's happening, the new operator is used to allocate memory dynamically at runtime, that is in a heap memory and is different from stack memory. Okay, that is in the heap memory where variables are stored. The type of the created int. Okay, what is heap memory and stack memory? Heap memory and stack memory, two types of memory serve different purposes and different categories. Stack memory, locally stack, is a regional memory that stores local variable and function. And for this automatic management, the memory of a local variable is automatically allocated and deallocated when the function is called and return size. Stack memory is typically smaller in size. Its size is limited. Access memory on the stack is usually faster to access because it operates in last in first out. Okay, different manner, last in first out. Okay, heap memory is a region memory that user then memory in the heap is not automatically managed. You must allocate memory explicitly using new and deallocate. It's using delete or delete for arrays. Heap memory is much more larger than stack memory. It is typically has much larger size limit, but it is limited by the amount of available system memory RAM access. Accessing heap memory is slower compared to stack memory as it involves more complex memory management. And okay, so this statement is requesting that the computer allocate enough memory for new int variable. Okay, new int variable. The operand and the new operator is the operand and the new operator is the data type of a variable being created. Once the statement execute, IPTR will contain the address of newly allocated memory. Okay, so we are saying like we create the pointer variable at first. We assign its value to null pointer. After that, we will say like we will store, we will say like new int. We need new int and it will store in pointer variable IPTR. Okay, and a value may be stored in the new variable by dereferencing the pointer. Any other operation may be performed on the new variable by simply using dereference pointer. Here are some examples. Example statement: cout display the contents of the new variable. Scene let the user input a variable. Sorry, value, not variable. Okay, display contents of new variable. Okay, yeah. So what's the value? It will display the value. Let the user input a value and total is like use new variable for in computation. Okay, so we are using. Okay, so we will do this at first, then we will do this. We need integers, we need integers. We will do this like, and we will use these operations like we can do sin or something like that. Not pool of unused memory variable. This chunk of memory start address. Okay. Although the statement above illustrates the use of new operator, there is little purpose in dynamically allocating a single variable. Or more practical use of the new operator is to dynamically create an array. Here is an example of how a 100 element array of an integer may be allocated. Okay. Oh, so in this way. So first we have to declare this, then this. So this is array, 100 element array. Once the array is created, the pointer may be used to subscript notation to access it. And for instance, the following loop could be used to store to count the value of 1 in each element. Store the value 1 in each element. Okay, so after that we can use the value, like use the pointers variables to manipulate the value or for calculation. But what if there isn't enough free memory to accommodate the request? What if the program asks for a chunk large enough to hold like 100,000 elements array of lots, and that much memory isn't available when the memory cannot be dynamically allocated? C++ throws an exception and terminates the program. Throwing an exception means the program signals that an error has occurred. You will learn more about exception in chapter 16. So yeah, I think I'm going to make like chapter 9, chapter 10, chapter 11, chapter 12, chapter 16. Okay, when a program is finished using dynamically allocated chunk of memory, it should release it for future use. Okay, when a program is finished after using the delete operator is used to free memory, and that was allocated with new. Here is an example how to delete is used to free single variable pointed to IPTR. Delete IPTR. So after using chunk of memory, we need to delete that for future use. Like for other programs. So we need to delete the information or delete the single. Delete the value. Okay, if IPTR points to a dynamically allocated array. Okay, if it points to dynamically allocated array, these symbols must be placed between delete and IPTR. So, oh, so it is for single variable. But what if we are doing this and we need to delete? We have to delete this because we need to use its memory for future programs. So we are doing delete this symbol, square brackets and IPTR. Failure to release dynamically allocated memory can cause program to have a memory leak. For example, suppose the following grab memory function is in a grab memory function is in a program. Void grab memory const in size 100. Okay, in size is 100. Allocate space for 100 elements, array of integer. Okay, IPTR new in size. The function ends without deleting the memory. Notice that the function dynamically allocates 100 element in the array and assign its address to IPTR pointer variable, but then the function ends without deleting the memory. Once the function has ended, the IPTR pointer variables no longer exist. As a result, the program does not have a pointer to dynamically allocate memory. Sorry, I got lost. But then the function ends without deleting the memory. Once the function has ended, the IPTR pointer variable no longer exists. As a result, the program does not have a pointer. This does not have a pointer to dynamically allocate memory. To dynamically allocated memory. does not have a pointer to that. Therefore, the memory cannot be accessed or deleted. It will sit unused as long as the program is running. Only use pointer with delete that were previously used with new. Okay, only use pointer with delete that. If you use pointer with delete, that does not reference dynamic unexpected problems could with each other. Okay, so I have to delete the memory that is used for dynamically allocated memory or dynamically memory allocation for dynamically allocation memory. If I use a pointer that is not used for dynamic memory allocation, then it will cause some problem. Okay, so I stream my menu. Okay, total average sales figures for anyone use. Okay, double sales NPTR to dynamically allocate an array, and this is accumulator total arrays. Okay, arrays to hold average sales in num days to hold the number of days of sales, count variable. Okay, okay, I'll be right back. I need to use the restroom. Okay, hello. So whereas double cells, no PTR, total is zero. Okay. So this is to dynamically allocate memory. Okay. Total is accumulator. I don't know. Okay. Oh, okay. Double total, double average, and in num days and count. Get the number of days to hold average cells, to hold a number of days of cells, counter variables. So what is the program? Like this program totals and average sales figures for any number of days. So totals and average sales. Okay, it will total amount of total. Okay, total sales and average of sales figures from number of days. Okay. How many days of sales figure do you wish to process? How many days of sales figure do you wish? Okay, num days. Dynamic array large enough to hold. Okay, num days. Oh, okay. Cells new double num days. Enter sales figures below. Mm, for count equals 0. So oh, okay, so it's like this. It's an array. It's making for array for making large enough to okay. Enter the sales figure below. Sales count. Mm. Okay, so if I got time, then I will try to like do this or just practice. And okay, oh, let me see. Delete it, delete. Then cells equals to null pointer makes cells equals to null pointer. Okay, yeah. No, is assigned to it is good practice to set a okay. Okay, so basically it is a good practice to set pointer variable to null pointer after using delete on it. First, it prevents code from inadvertently using the pointers to access the area of location that was freed. It prevents the code from inadvertently using the pointer. Second, it prevents error from occurring if delete is accidentally called on a pointer again. The delete operator is designed to have no effect when used on a null pointer. Okay. Okay. It prevents code. So what is this? Like I did not understand the first. Like it, first, it prevents code from inadvertently using the pointer to access the area of memory that was freed. Concept function can return pointers. So this how oh my bad. Function can return oh sorry. After using delete on it, first it prevents code from okay. Focus on software engineering returning to pointers from function. Focus on software engineering returning pointers. Function can return pointers, but you must be sure the function can return pointers. Okay, but you must be sure that the items that the pointer reference still exist. But must be sure the item the pointer reference still exists. Like any other data type, function may return pointers. For example, the following function locates the null terminator and appears at the end of a string, such as a string literal, and returns a pointer to it. Null terminator and appears at the end of a string. It's our final, it's our string. Oh, so we are returning pointer. Okay, uh, function may return pointers. For example, function locus null terminator that appears at the end of a string, such as string literals, and returns pointers to it. Okay, sorry string locus null. Okay, so this is pointer. Yeah, it is using uh, it is using another value for that. So it's our pointer now. PTR, we are creating new pointer variable, and we are storing the address in here. If address is not equals to, what is this? It seems you are asking for I thought I paste that. Explain this please. Okay. Okay, function purpose final. Okay, function purpose is final is designed to file null terminator. Oh yeah, I was like thinking like where did I saw that null terminator? Yeah, in our C strings and it return pointer to that position. It returns pointer to that positions. In C string are arrays of characters terminated by special characters, null pointers, null characters to indicate the end of the string parameters. This is a pointer beginning of C style string. Okay. Okay, so um find null. Okay, I will come back to this later because I I got to know that like it's like finding null terminator and returning pointer to that position. Arrays of character terminated by special character. Okay, null. Okay, parameters character string, character string. Okay, yeah. This is parameters. This is a pointer of the beginning of C string. Okay. Uh, Initialize the pointer. So ptr start by pointing at the beginning of the string. Is this array? No, it's not array. Ptr is a pointer of type char and it is initialized to point the first character of input string. So ptr start by pointing at the beginning of the string. Okay, I did not understand this, but I know this. What is this means? While loop start by pointing at the beginning of the string. Okay. Oh, okay, okay. Oh, we are working with C string. Yeah, I think we are working with C string here. Okay. While ptr is not null terminator, the loop continues as long as the character at the position ptr is not the null terminator. Ptr dereferences the pointer, so it takes the value that ptr is pointing to. The condition ptr is not equals to null terminator, instead that the loop keeps running as long as ptr points to character that's not null character. Okay, now I think I am understanding something like, so this is for pointer. We are taking value of string. We are storing address of string. Oh, we are not. This would be address sign, but here ptr is a pointer of character type and is initialized to point the first character. Point the first character. Oh, character of input string. Okay, beginning. While ptr is not equals to 0, ptr plus plus. Ptr plus plus. So the char return type in the function header indicates that the function returns a pointer to character. Get full name. Okay, yeah. This is a string, and we are returning. The problem, of course, is the function returns a pointer to an array that no longer exists because the whole array is defined locally and is destroyed when the function terminates. Attempting to use pointer will result in a Here is no parameter. Here is okay, string parameter. This is also acceptable. This is acceptable. This is acceptable. This is not acceptable because here is not parameter and no, declaration like pointer declaration like full name, string full name, like like manipulation, like if there is no parameter, then we can do is like memory allocation, dynamic memory allocation, where it is done here. Okay, okay. Okay, whoa. This program demonstrates the function that returns a pointer for rand and srand. I think we are doing something with for time function. Yeah. Function prototype get random number int. Okay. Okay, I think we are done with this. Like, I think we are. I think I am done for today. I will just complete this, and I think we are done. Okay, we are here. So this program demonstrates a function that returns a pointer, include iostream, include ctst leave, okay, int number. So here we are declaring num pointer variable with num pointer and numbers. We are calling the function. Yeah, we are calling the function. Then it's like have we used new? No, we are. I think we are using inside the function. So count zero, count down is five. Okay, count down. Okay, display. Okay, here number array null pointer, return null pointer if num is 0 or negative. If num is smaller or greater than 0, return null pointer. If num, okay, num is return null pointer. Yeah, because if num is smaller than 0, then this will be negative. And okay, dynamically allocate the array. Okay, we are creating array. Yeah. See the random number generated by Python. Oh, to the it can be any value like num. And after this, we are calling another function. Yes, rand. I think this is the srand. Okay, this is a time zero. What is it? Oh, okay. So we are going to populate, or we are going to um, manipulate time zero with random numbers for in count equals zero, count plus plus. Okay. So what is up, guys? I think we did like 3 hours of streams. I think it. I think almost 2.5 hours of a stream, and yeah, how to win any hackathon. I really like him. He's like very underrated. So guys, I think uh, I will try to cover up this, like, you know make I want to go through all this program. I have some project which definitely uses all this thing. I think my project is a lot harder. I'm trying to make videos on my project as well, but I don't, like, uh, like it's hard, but it's for, I think I will try to make one video on my this project number three, because this project number three is very interesting. Like, even I don't think, like, if I search in YouTube, there is going to be any explanation to that project. It's very interesting, and it uses many pointers, double array, and like using reference with arrays, double arrays. So that would be interesting. And yeah, that's all. And additionally, I will also cover. I will not go through with this, like chapter 1, chapter 2, introduction to C++. No, uh, I will try to go from chapter 9, because like everybody knows this. I I want to learn all this, like 16 stacks and queues recursion. So I think I will try to make video daily. Let's hope. Thank you guys. Bye bye.